Great job, Michael. And if you want to type in any big takeaways you have here, just head on over again to pollev.com/MAK. So our next presenter that we have coming up here right now is Alexander Demidko. I hope I pronounced your name right. Where are you, Alexander? You're right here? All right, fabulous. So if you want to get ready, Lee's going to get you hooked up. We're going to take about a 5-minute break again just to keep things on track. But earlier, if you did a poll a little while ago about what your biggest goal was that you want to take away from, what was it so far, and what have you found out? I'm curious what your biggest takeaway from the presentation so far has been. All of them together. Anyone? Any big takeaways? I'm going to pick on someone then. How about you? Regulation? Just about a lot of it coming? Yep. Right. So the bottom line is make sure your rear end's covered before you issue a token, because you could get haunted later on. Yep. Right. Right on. Good. Anyone else? Who else do I get to pick on? You, sir. Okay, biggest takeaway since you've been here at the event. How many sessions have you sat in so far? Yep. What's one?
I don't know.
Just really good. Yeah, think about it. How about you? What you got?
Just the variance of products. Like, it's just so broad. You know, I came in with some expectations to see a lot of different things, but it's getting blown away by just the breadth of the different products and how far people are going in different directions and down rabbit holes I never would have even thought about, you know?
So what have you seen anything specific that you were interested in, like you would actually invest in so far that looks like it's got big potential?
Yeah, the iComply ICO presentation that they did at the other venue was really good. MLG's was great as well. Seems like if you're looking at doing anything in the ICO space, getting his type of support and consulting services would be a very smart thing to do, you know?
Bottom line, so you've got great launch support, get the right attention, make sure you've got, I know there was a presentation, someone talking about just landing pages, for example, just optimization. So you had one now?
Yes. Even that's not quite that close. They were still very early in the field, and even though it seems that blockchain has been around for a decade and a number of things have already been locked up, that's far from the case. And I think there'll be, it's clear that even over the next decade, companies that seem to have a lead in various sub-niches now will be supplanted by startups that haven't even been envisioned. So there's plenty of time to come up with bright ideas and be a dominant player.
Right. Bottom line, it's not too late to get involved. All right. Who else? Got an observation? Something you want to share? All right. I'll do one more here. All right. I'll walk through here. We'll step on some feet. All right. What you got?
Just a very simple appreciation of the bread wallet and the presentation that guy did for people who are just now starting up. So I like that presentation. It's something I'll take away.
Good. So the bottom line is it's making it easier for introductory people to get involved and start carrying it around without so much confusion. If there's one thing that needs to be simplified, that's it for sure. All right. You ready to rock and roll? Next presenter. All right. So we've got Alexander Demidko, correct? Take it away.
All right. Hey, folks. Could I get the next slide? Cool. All right. Let me introduce myself. I'm co-founder and a research engineer at Fluence. So this talk is going to be like a little bit more technical. Oh, okay. Thanks. And I know that was like a long day, but I hope you can, get some more bits of new information today. So I'm going to talk about building decentralized database networks, what this concept is, why is it needed, and how it could be built. So the blockchain technologies are allowing to build decentralized networks. And we know that they are being used a lot for the cryptocurrencies use, like Ethereum and Bitcoin. But more often than not, like it also can be used to build decentralized applications. And decentralized applications, like they have multiple usages. So for example, there are projects that are basically using the CPUs to compute some, like basically to do some computations. For example, you can sequence DNAs, or you can train machine learning models, or you can render video scenes for the movie industries. And by the way, that like it's not you are wasting electricity to just do some computations. You're actually doing some useful work for society. You can also imagine decentralized web services, for example. Imagine websites that completely independent from governments and completely independent from the hosting providers. So like no organization is able to put those websites down. You can also think about encrypted messengers, like end-to-end encrypted messengers that no country can take down either, or decentralized data marketplaces where people can share their data without a single authority. So we can see that the blockchain technologies cannot be used only for the cryptocurrencies. They can also be used for building decentralized applications. And the question is, how and where these decentralized applications are going to store their data, because they obviously need to store it somewhere. So before we are going to answer this question, let's just take a look at how the data is being stored in a centralized world. So speaking very, very, very roughly, in a centralized world, the data is stored in two flavors, structured data and unstructured data. And structured data you can store, well, again, very roughly, in databases. And unstructured data you can store in files. So if you think about that, files are usually like black boxes. You can't really, search in them fast. And databases, you can think of databases as, giant linked spreadsheets which are linked together. So the difference becomes even more important when, say, for example, your data is being stored on a remote machine. If it's a file and it's stored on a remote machine, and you want, say, for example, to derive some useful insights, what do? Like, let's take, for example, a healthcare example. You have a hospital and you have a list of patients, and you want to find those patients that are going to be released tomorrow, let out from the hospital. So if this list of patients is stored in a file, well, you probably have to scan the entire file, and that might take some time. Even more, sometimes you even have to download this file to your local machine, and that might take some time as well, and that's not very performance-wise. On the contrary, with databases, you usually have like some special index structures. So these index structures allow you to scan them fairly efficiently. So in this example, we have Alice and Bob that are going to be released this Monday, and the index basically points to them, and you can find them right away and transfer only those records to your client machine. So that's a difference in performance. And if, say, for example, you have thousands or millions patients in your hospitals, but only a few that are going to be released tomorrow, the difference in performance can be thousands. So let's get back to our our decentralized world. So where would we store the data there? Well, let's say, for example, we are going to store the data on the blockchain. The cost of data storage, like these numbers, they're not the latest ones, but the cost of storage of the data on the blockchain can be pretty high, right? So it might take a few $1 million or a few days to upload the data, just like 1 gigabyte of information. So that might be really expensive. Let's say, for example, just for the comparison, let's check how much data does the English Wikipedia have. Articles, 14-ish gigabytes compressed. These are just last week results. And the history of edits, because we really want to care about like who has edited which pages and when. The history of edits is like 120 something gigabytes. To store all the data on the blockchain will probably cost you like few $100 million, and I'm not sure if the donations to Wikipedia will be able to cover that. Well, especially if you consider that there are other languages rather than English. So that's why decentralized file storages were created. To name just a few, Filecoin, which has raised 200 million something recently, Storage OSEA. And these file storages, like they should work really well. But again, what if I don't really want to download the entire data on my local machine? What if I want to just find only those patients that are going to be released tomorrow, like in our centralized world example? That's why we might want to use, instead of decentralized file storage, we might want to use a decentralized database. And this decentralized database has a number of challenges to solve first. And that's where things can become a little bit more technical. So the first challenge is how you replicate the data. So if you store the data on the blockchain, well, mostly every machine on the blockchain stores the same data copy. And this works fine because you have some sort of redundancy. If some of the machines go down, well, you have other machines that cover you. But that might be a little bit too expensive because, again, we want to store gigabytes of data or terabytes or maybe like petabytes of data. So what you can do with this, instead of just storing every copy, every copy on every machine, you can group your machine into clusters. And clusters, each cluster will be storing same data, but different clusters will store different data. So this allows you, first of all, this reduces your costs, but you still have decentralization, and your data still can be distributed geographically in different locations. So when, say, for example, and like one of the nodes is going down or acting maliciously or, cut from the network by the government, your data is still not lost. And that's definitely less expensive than on the blockchain. There are other challenges that has to be solved. So say, for example, my data is stored somewhere in the network, but we cannot really trust machines in the network. So when I'm making a query to the machine, how do I know that this machine has returned me correct results? What if, for example, this machine is storing the list of patients in the hospital, but when I ask it which patients are going to be released tomorrow, it tells me, well, there are just no patients at all. How do I make sure that the response was correct if I, the client, do not store the data on this machine, on my local machine? Is there really a way to check that? Well, there is, and we can call it, proof of query. The way how you deal with that, you can take your database state and compute a tiny signature of that, like really, really tiny, and store this tiny signature on the blockchain. Every time when the database state changes, like say, for example, new patients arrive to your hospital or patients are released from the hospital, you update this state on the blockchain. And now there are algorithms that allow your client to take this signature, basically a fingerprint, to read it from the blockchain, and the blockchain in this case will be a source of truth. And then using this signature to check that the response was correct. So that's, I guess, pretty cool. Another challenge is that if you allow your client and database, like machines that are storing your database, to interact through the blockchain, that might become too slow. Remember, we have spoken that the Bitcoin is processing just like few transactions per second. So to give you some perspective, modern databases are able to process hundreds and thousands of queries per second just on a single machine. So we really need something that works fast. So in this case, what we can do, we can have some sort of query channels. Query channels is basically when the client and the database, they are talking directly with each other. And only periodically they sync their state to the blockchain. If you have ever heard about Lightning Network or other off-chain transaction processing for Bitcoin or Ethereum, that's what it is. Although, just for the Lightning Network, these off-chain blockchains, they store financial transactions. And in the decentralized database case, they will be storing queries and responses. So that's pretty similar, right? One more challenge is, how do you deal with encryption? Because you deal with trustless machines, you can't really store data not encrypted. They might want to, steal your secrets from there. If you were storing files, it would be really easy. You just, encrypt the file, upload it to this database machine. When you need it, you download that. But what if you really want to perform queries over this encrypted data? So there are algorithms that allow you to perform queries over encrypted data. Basically, you don't want to download the entire data on your local machine. You just have to download a little bit to perform queries in a performance ways. But that's still a very active area of research. Basically, right now, you still have to choose a trade-off between how much structure of the data you expose and queries performance. If you expose too much structure, yes, you can perform really performant queries, but that might also have some data leaks. For example, you can leak how many patients are being kept in the hospital, and you don't really want that. Another challenge is, again, the network. You cannot really trust machines in the network. So let's say, for example, I'm a client and I have put my data in there, but then all of the machines in the network have disappeared with my data. Like, say, for example, all of those machines went down. Well, at least I want to get some huge compensation for that. Or, for example, what is going to happen if the client won't pay the database? So to solve this problem, you can basically use security deposits. Before signing a smart contract, the client and the database, they put some collaterals into the contract and sign that. And this contract is being stored on the blockchain. So now, if, say, for example, database, like the client is not paying those nodes, it can be fined for its security deposit. Also, the security deposit prevents machines from going down, because the node knows that if it goes down, it will probably just lose its security deposit. And final problem, I guess, is you need to have an open market for the node owners and clients to find each other. Basically, different clients have different workloads, different dataset sizes, and different query types. Again, different nodes also have different hardware. And what we want to have, we want to let clients and nodes to find each other. And so basically, every node will be compensated accordingly to its hardware. And these are just like some few use cases. I personally really like the public data use case, because in this case, you don't really have to encrypt that, so you get all of the power for queries. Like, you can use really advanced, for example, SQL statements to perform queries. But there are other use cases. You can store, logs from your electronical scales. In the decentralized database, you can store financial data there, and so on and so on. And just a few more use cases. And here, I guess I like the unstoppable content, just because no government in the world will be able, to shut down these websites. I guess that's it, what I was going to tell you today. Then that's what we are working at Fluence. And if you guys are interested in using this technology feel free to visit our website or join our Telegram group. Thanks for your attention. Sure. I kinda did. Well, I mean, if you're really interested in how it works in details, you can visit the website, and it has a paper there, so you can take a look at that, and it basically explains all of these problems in more details. Sure. Right. So that's basically the difference between, remember in the centralized world, there was a difference between files and databases. So these are file storages. They're basically content storages. And we are a database network. Say it again, please. Oh, they're just like a decentralized database. So different machines on the network are storing your data. And these machines are basically like miners nodes. So anyone can join the network. The same way like different miners can join Filecoin network if they want. More questions? All right. Well, thanks.
Very nice job.